Today we're going to talk about limits of trig functions, and it's definitely been a while since we've talked about limits. So let's just start with a general review of limits. So the main thing I want you guys to remember about limits is when I ask you a limit question, I'm not asking you what happens at a certain x value. I'm asking what happens very close to that value. So here's our notation. We have the limit as x approaches a of f of x. Now what that's saying is when x approaches a, or when x gets very, 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 very close to a without quite getting there, what's happening? Now, as far as how you're going to do the problems, one of the things way back at the beginning of limits, we said no matter what, with any limit question, you always try direct substitution first. Because if it works, that's the answer and it's a very simple question. Also, if it doesn't work, it tells you what you need to do. So when you try direct substitution, you could, number one, like I said, just get the answer. If I plug in 2 for x and it comes out as 10, then the answer to the question is 10. Now the other two things that can happen, number one or number two on the notes, is you could get any constant over 0, any number over 0. What that tells you visually is that there's a vertical asymptote there, and the answer to the question is either going to be positive infinity, negative infinity, or does not exist. And you'll look at a graph to decide that. It depends on what it looks like. So remember, if you have an asymptote, and on both sides of the asymptote, the graph is turning up, then the answer is positive infinity. If at both sides of the asymptote they're turning down, then it's negative infinity. And if you get one of those, one of each, one up and one down, that's when it does not exist. Now, the third one, which is the one we spent the most time on, is when you get what's called an indeterminate form. So if you get 0 over 0, or infinity over infinity, those are the two we focused on. There are other indeterminate forms, but those are the two we focused on. When you get that, what it means is there is an answer to the question, but you have to do more work to get it. So the way we did it, we learned limits and it was kind of hard the first way. And then after we had learned derivatives, we went back and we learned what's called L'Hopital's rule. Remember, it looks kind of like Les Hospital's rule, but it's pronounced L'Hopital's rule. And it's an easier way of doing those derivatives or doing those limits using derivatives when you get the indeterminate form. So basically, if you have an indeterminate form, if you have that some sort of rational function, some sort of fraction, and you get 0 over 0 or infinity over infinity, all you have to do is take the derivative of the top and bottom separately. And I typed into the notes, you're not doing quotient rule. This is not the derivative of the function itself, it's the derivative of the top and the bottom separately. And then try the limit again. Now, when it comes to infinite limits, meaning if you take the limit as x approaches positive or negative infinity, for most trig functions, the answer is going to be does not exist. And if you think about it, let's say, for example, we're looking at the graph of sine x. Sine x looks like this. And if you're doing the limit as x approaches positive infinity, way over here, or negative infinity, way over here, you're never getting an answer because it's what's called an oscillating function. It keeps going back and forth, back and forth. It's not going to one value. It's going up to 1 and down to -1 and back and forth and back and forth. So many times for most trig functions, if we're doing the limit as x approaches positive infinity or negative infinity, the answer is going to be does not exist. All right, so let's do a few examples together, and then that'll be it. So we'll start with this one, the limit as x approaches pi of sine of x. So remember, we said, number one, before you even think about the graph or L'Hopital's rule or anything like that, the very first thing you do is direct substitution, which means take this number here, pi, and just plug it in for x. And forget about the limit part, just the function itself. So the first thing I'm going to check is just sine of pi. Now if you get an answer for that, then it's the answer to the question, you're done. And we do get an answer for that because that's a unit circle question. On the unit circle, the sine of pi is 0. Pi is directly to the left or 180 degrees. So the answer to this question, basically, it wasn't really a limit question, it was just a unit circle question. What's sine of pi? It's 0. So that's an example of an easy one. Let's try the limit as x approaches pi of cotangent x instead of sine x. Now, when you get one of these trig functions, if you get a secant or a cosecant or a tangent or a cotangent, you probably want to take a second and rewrite it in terms of sine and cosine so we can see if we can answer it on the unit circle. So we have, oops, not x approaches x, we have x approaching pi of, and cotangent x is cosine x over sine x. So now I'm going to try direct substitution over there. So what I would have is cosine pi over sine pi, which would be 1 over 0. Those are unit circles again. So we get 1 over 0, and remember, any constant over 0 means we found an asymptote. We have a vertical asymptote at x equals pi. But to actually answer the limit question, we need to know what it looks like, because remember, the answer could be positive infinity, or negative infinity, or does not exist. Now, if you take a look at the graph of tangent pi, let's say pi, or cotangent pi, what it's going to look like is this, and this is pi right here. So what you have is the limit on the right is going to positive infinity, the limit on the left is going to negative infinity, so the answer to the question is does not exist. 1 up, 1 down on either side of an asymptote means the limit does not exist. Okay, let's do one last example. We have the limit as x approaches 0 this time of tangent x over sine x. So let's do the direct substitution part. It's basically tangent 0 over sine 0. Oops, not theta, it's a 0. And both of those are 0. So this is our third possibility. I did our example so it kind of matched up with our notes. The first one was direct substitution. The second was an asymptote. This is an indeterminate form. It's a 0 over 0. Now there's a few ways to take care of this. Let's do L'Hopital's rule first, because I'm going to show you 2 different ways to solve this one. But let's do L'Hopital's rule first. So the way L'Hopital's rule works, you leave the limit part. It's still the limit as x approaches 0. And then for your function, you're going to take the derivative of the top and bottom separately. So on top, the derivative of tangent x is secant squared x. And on bottom, the derivative of sine x is cosine x. Now we try direct substitution again. So I'm basically going to try secant squared of 0 over cosine of 0. Now cosine of 0 is 1. Secant of 0 is also 1 because it's the reciprocal of cosine, and the reciprocal of 1 is 1. So basically we have 1 squared over 1. The answer to this question is 1. And that's a review of L'Hopital's rule, where we took the derivative of the top and the bottom separately and then tried the limit again. Now remember, you only do that when you get the indeterminate form. If you think back to our last example with the asymptote, which was 1 over 0, if you do L'Hopital's rule on that question, it's going to give you the wrong answer. So it's important for you guys to remember L'Hopital's rule is for the indeterminate form only. All right, I did say I want to show you this example 2 different ways though. So if we go back to the beginning, another way would be more like what we did last chapter using identities. Before I even tried, let's say I tried direct substitution. We always do that first. So I tried direct substitution, I got my 0 over 0. Instead of L'Hopital's rule, what if I wrote this tangent x as sine x over cosine x? And then the sine x, if I basically kind of think of it as sine x over 1, then what happens is those sine x's cancel. And what you get is just the limit as x approaches 0 of 1 over cosine x. Now by direct substitution, you have 1 over cosine 0, 0 not theta, And then we just figured out on the last time we worked this example, cosine of theta is 1. So you get 1 over 1, same answer, 1. So it wasn't really that one way was easier or harder than the other way. It's just sort of, here's two different ways of thinking about it, and both of them work. It's good to take a look at different ways to solve questions.